by the National Socio-Environmental Synthesis Center. My co-authors are Meg Mills-Novoa, Elizabeth Schaffner, Jose Ochoa, Aldo Farah, and Eva Kinnebrew. And we are working on synthesizing quantitative and qualitative understandings of deforestation drivers and solutions in protected areas in the Amazon. And thank you so much for coming. To start off, here is an outline of the talk. I'm going to go through our motivation, research questions, study areas, our methodology, preliminary results, and then the benefits of this synthesis as we see them. So our motivation starts with Amazonian forest loss. There's this continued challenge of deforestation in the Amazon, particularly in protected areas. In 2019, for the second year in a row, Brazil reported an increase in deforestation. And across the Amazon, protected areas like Tinigua National Park in Colombia, pictured here, face escalating human pressure with increases in deforestation and agricultural expansion driven by interacting political and socioeconomic forces at multiple spatial scales. So, given these complex problems, we wanted to develop an interdisciplinary and action-oriented framework to study deforestation. The drivers of deforestation are complex and result from interacting social and environmental contexts. In order to develop interventions to reduce deforestation in protected areas, we need to understand the factors that increase the probability of forest loss. And in order to identify these drivers and potential solutions, we need to integrate quantitative and qualitative methodologies and data. Now, there are existing frameworks for integrating these different methodologies in land use modeling, and we did a review of the literature that I'll talk about at the end of this presentation and found a couple different ways that people are bringing together these different data types, including a more nested type where one data type is kind of more dominant than the other, parallel where quantitative and qualitative methods are used to answer the same question but not in conversation with each other, unidirectional synthesis where one method is feeding into the other, and then bidirectional synthesis, which is a lot less common in the literature because it's hard to pull off, and that's what we're trying to do here. So, research questions. We are interested in identifying factors that are drivers or solutions of forest conversion to agriculture in 3 protected areas in the Amazon. And then we ask, how can we integrate qualitative and quantitative methods to better understand the factors that contribute to or mitigate forest conversion to agriculture in these protected areas? So to be able to assemble and interpret the rich qualitative data we're interested in, we took a case study approach that allowed us to compare dynamics across 3 protected area complexes: Xamanchín National Forest, Tambopata National Reserve and Bahuaja-Sonene National Park, and Amboró and Carrasco National Parks. We chose these 3 case studies because all of them have experienced forest loss and conversion to agriculture, and they're about the same size but have different socioeconomic and political dynamics. Also worth noting, for this study we included the protected area complexes and then added a 10-kilometer and 20-kilometer buffer around the protected areas to account for what's going on directly outside the protected area. Okay, so now I'm going to walk you through our methodological concept map. So a traditional land use change modeling study might take land cover maps developed through remote sensing, choose variables related to forest loss or hypothesized to be related to forest loss, run them through a quantitative land cover model, and spit out results. And that's a valid way of understanding what's going on. Another model of looking at this would be to do that quantitative study and then in parallel have a more qualitative analysis drawing on a method such as discourse analysis to look at what's going on. So what we've decided to do is take both of these methods and then have them in conversation. So we have discourse analysis helping us with variable selection that feeds into land cover modeling. And then the variables that come out of land cover modeling as being significant then help us refine our discourse analysis, which helps us develop this idea of emergent themes and relationships between variables, which again feeds into another round of land cover modeling. And then we bring all of that together and compare the different models and interpret and integrate the different methodologies in order to get a better understanding of what's going on. And kind of crucially here, we're not only interested in what's going on the ground, what are the drivers of deforestation, we're also interested in how those drivers are being conceptualized. And that's something I'm going to come back to when I talk about discourse analysis. Okay, so to walk you through our methods, For remote sensing, we used GeoSurvey to classify training sites across our 3 case studies. And then using Google Earth Engine, we developed land cover maps for 2008 and 2018. And this is to give you an example of what our classifications look like. Forest is in green, agriculture is in yellow, and this is Zhemanqing National Forest. And zooming in on an area that has quite a bit of forest loss over that time period, just to give you a sense. And our validation accuracy was over 90% for all 3 case study sites. So our second main methodology, discourse analysis. This is a qualitative method that examines how language and text shape worldviews, challenging claims of objective truth, and explaining how some ideas and people come to dominate discussions about a particular topic. Here, protected area conversion to agriculture. We use discourse analysis to examine how the social construction of the problem, the impact of agricultural frontiers in conservation areas, determines how this problem is articulated, managed, and contested through environmental governance, with consequences for biodiversity protection and human well-being. So basically, we're arguing that the way that deforestation is understood and talked about limits the potential policy interventions that are put in place, which in turn is going to have an effect on whether those interventions are effective. So for our discourse analysis, we assembled a bunch of data sources for the 3 protected area complexes. We looked at management, policy documents, as well as gray literature, which were NGO reports, institute reports, government reports, and also advocacy documents. And we extracted key themes, variables, and processes, looking at the drivers of deforestation, factors hypothesized to mitigate deforestation or proposed solutions, and then also processes and relationships between the variables. And this allowed us to do this mapping of the different drivers, and then I'll show you solutions on the next slide. And I'm not going to get into a ton of detail about this because this is kind of just a preliminary visualization just for our own purposes, but I want to show you the type of themes that come out for one of our case study sites. So things like roads and poverty and illegal logging and ranching and migration are all identified as things contributing to deforestation, as are kind of more abstract things that are harder to put on a map, such as lack of state capacity and coordination and corruption. In terms of solutions for that same park, things like forestry policy, local scale projects, ecotourism, payments for ecosystem services. And again, these things are not necessarily things that are always put in land use change models. And for good reason, some of them are quite difficult to kind of turn into a spatial quantitative data layer that we can include. But again, just important things that are being talked about. Okay, so where we bring all of these things together is in our land use models. And I'm going to walk, to do the land use models, we used logistic regression to identify factors related to forest loss and compare them across the case studies. And for each case study, we ran 4 models with different suites of variables. And so these models are, and I'm going to go through them here, and then a couple other ways to help you understand how they differ. Model 1 uses standard variables for land use change modeling. Model 2 is just discourse analysis variables. Model 3 brings in all those variables from Model 1 and Model 2, so kind of a kitchen sink approach. And then Model 4 is standard variables that were statistically significant in Model 1, plus the discourse analysis variables that we identified as being key through our qualitative analysis. So, just looking at how the variables feed in for each model, this is more of a standard land use change model, bringing in land cover maps, a review of the literature to select variables. So this is Model 1. Model 2, over here you can see how we've got the discourse analysis and iterating and feeding into a model with just the discourse analysis variables. Model 3, so here you've got the themes coming out of the discourse analysis that then turn into Model 3, which gives us this kind of kitchen sink one again. And then Model 4, where we've got this iteration and refinement leading to a subset of variables from Model 3. So to make this a little more concrete, I'm going to walk through these models and what they looked like for one of our case studies, Carrasco and Amboro National Parks in Bolivia. And I'm sorry, I just realized I have Carrasco up there twice. My apologies. So this protected area complex consists of Carrasco National Park, Amboro National Park, Amboro IMNA, which is an integrated management area, and then the 10-kilometer buffer and 20-kilometer buffer that you can see here. Okay, and so the variables in the first model, distance to roads, rivers, population density, poverty rate, precipitation, soil moisture, topography, distance to cities, distance to legal mines, protection status. So here we said whether a point was in each of the different kind of protected areas or buffers within that map I showed you before, and crop suitability. And it's worth noting that for protection status, Amboro National Park served as the reference level for this variable, so the effects of the other protection statuses are compared to Amboro. So model results, and I'm not going to kind of belabor this because I just wanted to give you a sense of how the model varies, how the models vary across the different variable subsets. That you can see here, kind of which variables stood out as increasing the probability of deforestation, decreasing the probability, or having no effect. Okay, and here the variable with the strongest relationship with forest loss was being in Amboro Inma, or the buffers relative to Amboro National Park. Okay, model 2. So here, these are entirely variables that came from the discourse analysis. So we've got distance to agriculture, distance to field research sites, illegal mines, distance to fire perimeters, fire density, distance to roads as a measure of accessibility, distance to tourist attractions and hotels, head of cattle, and then this one that is in brackets because we haven't actually tracked down the data layer yet, but we're hoping to add it, which is land titling and tenure. And so here you can see again the variables that are associated with an increased versus decreased probability of deforestation, and then cattle density had no effect. Model 3, so here this again is kind of the kitchen sink model where we've got all the variables from Model 1, which came from just standard land use change literature, all the variables from Model 2, which were the discourse analysis variables, all mixed together. And so as a result of those, we again get a sense of which variables increase versus decrease the probability or have no effect. And then finally, Model 4 just pulls out the variables that were significantly significant in Model 1, or that we identified as key variables through discourse analysis using qualitative methods. And so here the variables are poverty rate, crop suitability, protection status, topography, distance to roads, rivers, and legal mines, latitude, head of cattle, distance to fire perimeters, fire density, presence of payments for ecosystem services programs, distance to tourist attractions and hotels, and then a couple other variables that we want to add but haven't developed yet. And here the variables that increase the probability of forest loss are being inside the Amboro integrated management area and the 10-kilometer buffer or 20-kilometer buffer, so increased probability of forest loss compared to being in Amboro National Park, fire density, distance to tourist sites, and latitude, while slope, aspect, elevation, distance to roads and fires, and presence of PES sites all decrease the probability of forest loss. So using some preliminary analysis, we found that Model 4 had the best model fit for forest transition to agriculture from 2008 to 2018, which is really interesting. We found that adding these variables that are not typically included in land use change models, but that are quite important in the discourse around deforestation, actually did improve model performance. Next steps, we want to model probability of forest loss using the different models and predict future deforestation hotspots, again, across all 4 models so we can compare how they differ in terms of their predictions and what they might tell managers they need to focus on in the future. We've also got this work coming out soon, hopefully after we submit it, looking at the way that quantitative and qualitative methods are synthesized across land use change literature. So in conclusion, we've found that iterative synthetic interdisciplinary approaches require collaboration and creativity. There are some challenges remaining, including asymmetrical integration, where we can't quite turn things from we can't quite integrate all of the qualitative analysis into our integration, and also temporal and spatial challenges around time lags. But we also think that this really adds value to land system science in terms of variable selection and model development, where this qualitative analysis really did enrich the variable selection. Also interpretation, this depth of knowledge about a case study site that arises from doing the discourse analysis really helps us understand our quantitative outputs. It gives us a way to compare across sites, and it also has really use-inspired outcomes. So we're really interested in what this means for managers and policymakers. And with that, I'd like to thank our external experts, Siniro Costa Jr. from Imaflora and Rachel Golden-Kroner from Conservation International, and also Succinct for funding us. Thank you.